Chapter Determinants, Exercise 4.6. Examine the consistency of the system of equations. Question number 1. X plus 2y is equals to 2. 2x plus 3y is equals to 3. So we have to check the consistency of the given system of linear equations. So solution. First we write the given system of linear equations in the matrix form, that is Ax is equals to B, where A is the coefficient matrix. If you write the coefficients of the variables, here coefficient of x is 1, coefficient of y is 2. In the second equation, coefficient of x is 2, coefficient of y is 3, and x is the column matrix containing the variables. The variables used are x and y, and B is the again column matrix containing the constants in the RHS of the equation. So that is matrix 2, 3. Now first compute the determinant of A. So determinant of A is equals to determinant of 1, 2, 2, 3. That is equals to, if you expand the determinant, that is 1 into 3 minus 2 into 2. So that is equals to 3 minus 4. That is minus 1, which is not equals to 0. So determinant of A is not equals to 0. So A is non-singular matrix. Since determinant is not equals to 0, so we can say that A is a non-singular matrix. And A has unique solution. So the system is consistent. So we can say that the given system of linear equation is consistent. Question number 3. X plus 3y is equals to 5. 2x plus 6y is equals to 8. Here also we have to check the consistency of the system of equations. Solution. So first we write the given system of linear equations in the matrix form, that is Ax is equals to B, where A is the coefficient matrix. If you write the coefficients of variables x and y, that is here x coefficient is 1, y coefficient is 3. In the second equation, coefficient of x is 2, coefficient of y is 6, and x is the column matrix containing the variables. The variables used in the equations are x and y, as well as B. B is the column matrix containing the constants in the RHS of the equation. Constants are 5, 8. Now let us check whether the matrix A is singular or non-singular. So consider determinant of A. So determinant of A is equals to determinant of 1, 3, 2, 6. So that is equals to, if you expand the determinant, that is 1 into 6 minus 3 into 2. That is equals to 1 into 6 is 6 minus 3 into 2 becomes 6. So 6 minus 6 is equals to 0. So determinant of A is equals to 0. Therefore A is the singular matrix. Since A is the singular matrix, let us compute adjoint of A. We know that adjoint of A is equals to transpose of the cofactor matrix, that is A11, A12, A21, A22, its transpose. Now let us compute the cofactors A11, A12, so on. Here the element A11 is 1. Its minor is the diagonally opposite element, that is 6, and cofactor A11. Here sum of the suffix 1 plus 1, that is 2 even. Whenever the sum of the suffix is even, cofactor will be same as minor. So the value of A11 becomes 6. Next A12 is equals to 3, that is second element in first row. Its minor is denoted by M12, is the diagonally opposite element, that is 2, and its cofactor A12. In this case, sum of the suffix 1 plus 2 becomes 3 odd. Whenever the sum of the suffix is odd, cofactor will be negative of the minor. So A12 value becomes minus 2. Next A21 is equals to 2. Its minor M21 becomes 3. Its cofactor A21 becomes minus 3. Also A22 6. Its minor M22 is 1, and cofactor A22 is equals to 1. Therefore adjoint of A is equals to, substitute the values. A11 means 6, A12 minus 2, A21 minus 3, A22 1, transpose. So transpose means we have to interchange rows and columns. So if you interchange rows and columns, write first row as first column, that is 6 minus 2. Write second row as second column, minus 3, 1. Now consider adjoint of A into B. That is equals to adjoint of A is the matrix 6 minus 3 minus 2 1 into matrix B. B is the matrix 5 8. That is equals to, find the product of these two matrices. If you multiply the corresponding elements of first row with first column, that is 6 into 5 plus minus 3 into 8. Similarly, if you multiply corresponding elements of second row with first column, that is minus 2 into 5 plus 1 into 8. So that is equals to 6 into 5 is 30 minus 3 into 8, that is 24, minus 2 into 5 minus 10 plus 1 into 8 becomes 8. So that is equals to 30 minus 24 becomes 6, minus 10 plus 8 becomes minus 2, which is not equals to 0 matrix. So adjoint of A into B is not equals to 0. So solution does not exist. Since adjoint of A into B not equals to 0, solution does not exist, and the system of equation is inconsistent. Whenever the solution does not exist, we call the system of linear equation is inconsistent.